Empty space is not empty. Every quantum field jitters even in its ground state, and that jitter is real, you can measure it. It is the Casimir attraction that pulls two metal plates together. It is the Lamb shift in hydrogen. It is the running of the couplings. So add the jitter up, mode by mode, and you get a number, the energy density of the vacuum, and gravity listens to every form of energy without exception. It has no filter. So take that sum seriously, cut it off where the substrate's own graininess forces you to, and gravity should have curled the entire observable universe into a region smaller than a single atom long before the first galaxy ever formed. It did not. The curvature we actually measure is smaller than the naive estimate by something like 120 orders of magnitude, the largest disagreement between theory and observation ever recorded. The worst prediction in physics. Now, I want to be blunt before we start, because this is the single most overclaimed topic in theoretical physics. This chapter does not make that number come out right. It shows why the largest and most frightening piece of the vacuum energy cannot curve anything at all, and then hands you back a smaller, honestly uncomputed remainder and calls that the real problem. That is the whole deal, nothing more. One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Let us restate the catastrophe in this theory's own notation, so we know exactly what we are trying to kill. On the substrate, the gapped rotor modes carry zero-point energy, every one of them. The lattice sets a maximum frequency, because you cannot have a wave shorter than the spacing between sites. That frequency is the cone speed divided by the lattice spacing. Give each cell one such quantum of energy, and divide by the volume of a cell, and you have the vacuum energy density. It comes out as h bar times the cone speed, divided by the lattice spacing to the fourth power. Notice what the lattice spacing is doing here. It is doing double duty, and this is the trap. It is the ultraviolet regulator that makes the sum finite instead of infinite, and precisely because it is the regulator, it is also what sets the sum's enormous size. Now feed that into the induced gravity of Chapter 8, where the emergent Newton constant scales as the lattice spacing squared. The spacings partly cancel, and you are left with an effective cosmological term of order 1 over the spacing squared, a curvature radius of order the lattice spacing itself. The entire observable universe crushed to subatomic size. This is standard physics correctly relabeled. We tag it standard and claim no credit. The question of the chapter is whether the substrate offers any structural reason to expect the real answer is smaller. Not by fitting. By asymmetry, the standard framing. The usual suspects are familiar and mostly disappointing, so let us line them up. Suspect 1, the counter term. Subtract a bare cosmological constant tune to cancel the disaster to 120 digits. It works in the sense that arithmetic always works. But it is a fit, not an explanation. You have written down the answer and called it a mechanism. Stamp it non-explanatory. Suspect 2, supersymmetry. Pair every bosonic jitter against a fermionic one, and the zero-point energies cancel exactly, in an exactly supersymmetric world. The world is not supersymmetric at any energy we can reach, and once you break the symmetry, the residue is still vastly larger than the observed value. Stamp it insufficient. Suspect 3, selection. In a landscape of many vacua, only the ones with small curvature last long enough to grow observers, so of course we find ourselves in one of those. This corpus takes no landscape. It is a statement about one substrate, not a selection over many. Stamp it declined. The chakra substrate offers none of these. It offers a fourth thing, structural and cheap, and here it is in one sentence. The emergent metric of part 2 is fixed by the massless sector only up to an overall Weyl factor, an overall stretching factor, and a spatially uniform vacuum energy is exactly a shift of that factor. It changes the definition of the meter. It does not change the shape of spacetime. Now we make that precise. Here is the fact the ordinary vacuum energy argument cannot see, because in ordinary physics the metric is handed to you as fundamental. In this theory it is not. The metric is read off from the two-point structure of the massless Goldstone sector, chapters 5 and 6. And what that sector actually determines is a densitized inverse metric, a weight function times the square root of minus g times the inverse. The crucial word is only. It fixes it only up to an overall local weight, and that weight is undetermined. The reason is one line of algebra. The massless equation of motion is a divergence of the densitized metric contracted with a gradient of the field set to 0. Multiply that densitized metric by any smooth positive function you like, and the equation is unchanged. So a massless field literally cannot tell a metric apart from a Weyless-scaled copy of it. The consequence, only the ratio of the spatial weight to the temporal weight is physical, and that ratio is the cone speed squared. The overall scale of the two together is pure gauge, not a fact about the world. Now, we have met this freedom before and it hurt. It is the same Weyl freedom that let us fix the lapse to 1 and gave the ultrastatic metric its notorious vanishing time-time curvature, the fact that convicted the dynamical lapse gravity program with a no-go in chapter 12. There it was a tax. Watch it become a rebate. Now the proposition, and it is almost embarrassingly simple. A perfectly homogeneous vacuum energy, the same at every site, shifts the temporal weight and the spatial weight by the same factor everywhere. Call it lambda. Then, the physical ratio goes from Zs over Zt to lambda Zs over lambda Zt, which is Zs over Zt, identical, point by point. Any residual global rescaling of the cone speed by the square root of lambda is a redefinition of the unit of length. Nothing the massless sector could ever report has changed. Homogeneity is the whole of the argument. Now feed that into the one exact object the gravity sector gives us. In chapter 6 we derived the emergent optical curvature from the conformal profile of the cone speed, and it has a particular shape, the cone speed squared, times 4 times the Laplacian of the log of the cone speed, minus twice the square of the gradient of the log of the cone speed. Look at what every term on the right has in common. Every one carries a spatial gradient. Curvature here is not sourced by the value of the light speed. It is sourced only by how the light speed varies from place to place. So, a spatially constant cone speed has 0 gradient and 0 Laplacian, identically, and the curvature is exactly 0. Not approximately. Exactly and independently of how large that constant piece is. Chain the two together, and that is the closure. Uniform vacuum energy implies a constant shift in the cone speed, implies pure Weyl gauge, implies 0 curvature. The whole h bar c over a0 to the 4th degravitates. It rescales the conformal factor everywhere by the same amount, and curvature only listens to gradients of that factor. The constant piece is gone. The gradients are not. Only the inhomogeneous part of the vacuum energy, the lumpiness, produces a non-zero gradient in the cone speed, so only the lumpiness survives into the curvature formula to source anything real. Written out, the residual curvature goes like the cone speed squared times the fractional cone speed fluctuation divided by the square of the correlation length of the vacuum fluctuations. And that fractional fluctuation is the vacuum energy fluctuation divided by a characteristic scale converting an energy shift into a conformal one. So the magnitude that actually gravitates is fixed by the correlation structure of the vacuum, not by the full 1 over the lattice spacing to the 4th. The leading, spatially constant term has dropped out before the question is even asked. Structurally, this is the old idea that only differences gravitate, the same physics as unimodular gravity, where the cosmological constant shows up as a non-dynamical integration constant rather than a source, and the same phenomenology as the degravitation program. We tag the residual standard because it is, and we hand the credit back. What is new as stated in this theory is only how the constant piece goes away. In unimodular gravity you remove it by fiat, fix the volume element by hand, and the constant is inert by construction. Here nobody imposes anything. It is removed automatically because the emergent metric is Weyl trivial and the massless sector that builds the meter stick is blind to a uniform stretch. Same conclusion, reached from the other end, forced rather than chosen. Let us put real numbers on it. Take the disaster at face value, cut the vacuum sum off at the Planck scale, and the theoretical density goes like the Planck mass to the 4th, 2 times 10 to the 19 gigaelectron volts, all raised to the 4th power. The observed dark energy density is about 2.3 times 10 to the minus 3 electron volts to the 4th power. Take the ratio. Inside the bracket you get roughly 5 times 10 to the 30, and raising that to the 4th gives about 10 to the 123. That is the celebrated 120 orders, and to be precise, the exponent slides with your choice of cutoff and is conventionally quoted anywhere from 120 to 123. In the standard framing, every last one of those orders has to be cancelled by hand. On the substrate the accounting is different. Split the vacuum's contribution to the cone speed into a uniform piece plus a fluctuation. The uniform piece carries the entire 10 to the 123, all of it, and it enters the curvature formula only through the gradient and the Laplacian of the log of the cone speed, both of which annihilate a constant. So the arithmetic that produced 10 to the 123 produces, in curvature, exactly 0. What is left is the fluctuation term, and the book cannot yet put a number on it. That is the relocated problem, stated as a problem. What it can say is this: the frightening 10 to the 123 is not the thing that has to be small. The fluctuation amplitude is a strictly smaller and better posed quantity, even though it remains uncomputed. Now the passage that matters more than any other in this series, because this is the topic where physics overclaims hardest. Let me say plainly what is not claimed. First, this does not compute the observed cosmological constant. Not approximately, not up to a factor. The theorem removes the uniform piece and relocates the whole problem into the size of the vacuum fluctuations, and that size is uncomputed. Nothing here shows the residual is small enough, let alone that it equals the measured dark energy density. Second, it inherits unimodular gravities. Why this value problem in full? Degravitating the constant piece says nothing about why the observed curvature is small and positive, nor why it dominates the expansion now, of all epochs. Untouched. Third, it assumes the Weyl freedom is exact for the uniform mode, which holds for the massless sector in isolation, at the level the calculation establishes. Radiative and inhomogeneous corrections, the Lorentz violation naturalness issue flagged as gap 4 elsewhere, could reintroduce a spatially constant piece through mode couplings, and that interplay is unexplored. If they do, the rebate is partly clawed back. Here is the cleanest way to hold it. The load-bearing step, that curvature vanishes for a constant cone speed, is exact, nothing but the chapter 6 formula evaluated on a constant. The speculative step is the claim that the vacuum energy's leading piece really is spatially uniform, and therefore lands on that exact step. That claim, and the size of what is left over, are where the honesty lives. One more thing you must hear. By this corpus's own accounting, logged in the Part 8 ledger, this is the weakest closure in the entire book, the lowest confidence entry in the set. It makes no sharp new observational prediction. It shares its phenomenology with unimodular gravity and the degravitation models, so any measurement excluding that class excludes this too. Verdict: the cosmological constant problem is not solved. It is reduced. A substrate native mechanism removes the dominant term. The enormous uniform vacuum energy cannot curve space because the massless sector that builds the metric is blind to a uniform stretch, and curvature here responds only to gradients. That step is exact and it is forced. What is handed back is a smaller, better posed, entirely uncomputed residual. Verdict: reduced and flagged as the weakest closure in the book, without softening. But this chapter is not the book's last word on the subject. Part 9 returns to the residual by a different route, not the correlation structure of the vacuum fluctuations, but a causal bound, the Lieb-Robinson factorization of Chapter 3, promoted into an ultraviolet infrared theorem, cuts the vacuum integral off at the future causal horizon rather than at the lattice spacing, and a gauge quotient count then fixes the remaining order 1 factor to the square root of 11 over 12, 12 being the dimension of the standard model gauge group, 11 the non-photon generators. That is Chapter 49, and the two results are complementary. Not competing, this chapter says why the uniform part does not curve space. Part 9 says what sets the scale of what is left. Neither subsumes the other, and Chapter 49 carries heavier hedges of its own. The phrase to use for it is closed within ACT, not closed. Its premises are asserted rather than derived, and it has not been assessed by the wider literature. Hold both verdicts at once. What would upgrade this chapter is one calculation nobody has done, the two-point function of the vacuum energy fluctuations on the rotor lattice, giving the amplitude and the correlation length. Then you could ask whether the residual is naturally of order the observed value or wildly off. Either answer would be progress. Next time, charge and why it comes in whole numbers. Topology on the lattice. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shivalinga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, please like the video and subscribe. It genuinely helps this work reach the people who will argue with it properly. And do leave a comment, tell me where you think I am wrong. Every chapter in this series names its own kill tests, and the objections are the point. The book and the next chapter are linked below. Until then, one substance and how far it reaches.